Hello YouTube. I wanted to make a short addendum to the video that I published yesterday entitled Flat Earth, the Impossible Horizon, Part 1. And this is just an addendum to Part 1, this is not Part 2. And the reason for the addendum is some comments that have been made in my in the comments section to this video, which are, I guess, valid, but I think slightly incorrect, and I just wish to clarify what my point of view is about the horizons that I was talking about. So the first thing is about definition of horizon. So in my video, I defined three types of horizon: a water-land horizon, a land-sky horizon, and even a land-land horizon. Now, horizon is classically defined as where the Earth's surface appears to meet the sky. Now, that actually allows for two horizons, a water-sky horizon or a land-sky horizon. And those meet the classic definition. But that definition is limited in what it allows us to describe about the real world. And I took the liberty of sort of redefining what I meant by horizon for the purposes of that video. I didn't want to start talking using other words different to horizon because I felt it would make everything rather confusing. So I stuck with the word horizon, and I felt I made it clear enough what I was talking about. The reason for the preamble at the start of the video is to make it clear what phenomena I'm actually referring to when I refer to a horizon, particularly a water-land horizon and a land-land horizon. People understand what is meant, I hope, by classical water-sky or land-sky horizons. Oops, back for a moment. So my response to people who have complained about my use of the word horizon is that if you don't like that word being used in the way that I've used it, then simply just substitute another word yourself for that as you're watching or reading anything that I've written. Perhaps the word boundary would be acceptable to you, or by all means, come up with another word. The key thing about the horizons I was describing is the way that they actually behave in reality. The horizons we see, whether they be water to sky or land to sky, or the additional ones that I described, a water-land or a land-land horizon, is that beyond that horizon, objects are obscured from our view by the horizon itself. The horizon is the top, if you like, of an object that is in front of us. This, in the case of water, is the water curving. In the case of a range of hills, it's those hills themselves. And at least the horizon at least partially blocks, or the object creating the horizon partially blocks our view of what is beyond. And that's what I was meaning by the word horizon. Now, the second point I'd like to make, and I'll just bring in all the animations here because they're not actually necessary, is about whether it's possible to have a water-land horizon on a flat Earth. And people have pointed out that from about 3.8 miles distance from an observer 6 foot above the water level, the human eye is incapable of resolving the water beyond this point. So all the water beyond this point would simply become part of the horizon line. And while this is actually true, the angular size becomes too small for the human eye to resolve. We have to remember that we possess binoculars and cameras with zoom lenses and telescopes. And using these devices, particularly in most people's case, a camera with a zoom lens, it is perfectly possible to resolve the water beyond 3.8 miles. Indeed, it can be, or in theory anyway, it's perfectly possible to resolve water beyond 3.8 miles. In practice, what happens is that there is a hard horizon at a particular distance dictated by the curvature of the Earth and the height of the observer. And beyond that point, the water cannot be brought into view with any kind of optical device, be it a pair of binoculars, a camera with a zoom lens, or an extremely small or even an extremely powerful telescope. Optical telescope would not be able to bring the water back into view. It is beyond the horizon, and the horizon bars prevents that water from coming into view. And this is the crucial point. And this is why it's fair to say there is no horizon here on a flat Earth. Because simply using one of those devices, one would be able to bring water that is well beyond that point into view. Exactly how far you'd be able to bring it into view would depend on how powerful the optical device was that you were using. But that's a part of what's going to be discussed in the next video in this series. So I hope that clarifies why I stated there was no horizon on a flat Earth in this particular example. And I hope it clarifies why I use the word horizon, perhaps to describe something that some people think should not be called a horizon. I was simply using the word horizon to describe things that we see in nature, which to all intents and purposes have the same properties as the more classical horizons that we see. So thanks for watching this. I hope that's cleared a few things up, and I can carry on working on part 2, which will be a very interesting, I hope, a very interesting video indeed.